Oh. Hey guys, what took so long? Where's he at? I thought he was downstairs.
He's coming down.
We're continuing with that practice exam. We're on to section B, question 2 now. We have to finish it. The projectiles part. So if you can open that, that'd be great. Yeah, we did A1 and 2, so 3 and 4 next. And then we'll get to B in a moment. Do you have it, Miss Sharif? Yeah, okay, well then go on. This must be now. Hey, we're continuing with the question. What was the delay downstairs?
Yeah.
The delay. Okay. What?
I tried the questions that I showed you earlier.
What? What?
No, I don't think so.
He didn't want to tell me what the delay is. He looked quite serious downstairs, so I didn't want to probe any further. Was it serious?
No.
He looked serious downstairs.
Did I?
He did. I was walking by thinking, what's up with Iyad? Okay, so do you have that question open there? Yes. How about we just finish this part actually, since we were in the middle of it before we braked. So we just last calculated the time, didn't we?
Yeah.
Yeah, so what's part 3 now?
The
The range? So the range would be the horizontal distance, speed multiplied by the time. So that's u cos theta multiplied by t. But we know the u, we worked it out as 30. We know the theta is given to us as 35. And we've just worked out the time. What was the time previously? I know you worked it out. You gave me an answer. It's Louis Sharif. He doesn't write things.
Did I write it? I don't know. Yeah, you did write it.
Yeah, so what's the time?
It's 30. It's about 30.
Yeah.
Oh, it was 4.8. Yeah.
4.8 or 4.38?
No,
It was 4 point something, I remember.
it was 7.8. 4.78. So I said 4.8.
Okay.
Yeah.
4.78 then. Right, so can you hit that in and give me now the range? And what's the last part here? The velocity,
What is it?
the ground. Velocity? Okay. So Vx equals ux plus axt, but there's no acceleration in the x direction, so it's the same as ux, which is u cos theta, which is cos 35. That's half the answer. And we can get that, please.
Yeah, 24.57.
24.57.
So always the velocity before it hits the ground is same as u.
Horizontally. And then V is, Vy is Uy plus Ayt, but this time there is an A. This will be U sine minus 9.81, 4.78. So what is that, please? And then we are finished this part. Yeah, should be a minus because it's going down.
Yeah.
So what is it?
29.68.
Minus. So minus 29.68. So 7.
Yeah.
Okay. What's the next part about? Is the ladder.
Yeah.
Yeah. Okay.
Yeah.
What is this? This is physics. Three-fourths theorem. Huh?
Yeah.
Or turning force. Statics. Turning force. Moments. Turning force. Torque. Yeah. Would it be good if I just did this one, because I feel like you don't remember how to do this. Because I'm looking at your face and your face says no.
You can.
You can do it. Are you sure you can? Alright, go ahead.
That's on the reader.
Yes, of course. Go ahead. Alright, give it a try, then I'll do it now. It's just, is it just a ladder up against the wall?
Yeah.
And what information do you know? I'll just draw it for us.
4.5 meters long, not 20.5.
Okay, so the ladder is 4.5 meters long
Not 20.5 kilograms.
and 20.5 kilograms. Yeah.
It's lower end, 1.5 from the wall.
Okay.
A man of mass 80 is standing vertically on the ladder.
Right, yeah. And they want to know how high or something he can climb the ladder? Probably. Anyways, it doesn't matter. So,
His feet 0.8 from the top.
alright, so he's like here, 0.8 from the top. And here he is here. And if the ladder is 0.8, so he's near the top actually.
It's 0.8. And the red is 1.8, not 1.5.
Okay. So this isn't actually three-force theorem because there's more than three forces on it. You have the weight of the ladder, and you have the weight of the man. Also, did they talk about friction here? Well, frictionless here. Yeah, but there's going to be. Yeah, that's it. There's got to be a reaction from the ground here. And also the ladder is not sliding because of friction. So you know the ladder wants to slide this way. So there's a friction force on the ground that must be acting this way. So this unfortunately is not a three force, it's a four force problem. So it's not a three force theorem problem, it's just a old fashioned turning force problem where the clockwise equals the anti-clockwise. So my hint I give to you is you want to pick a good turning point for this problem.
I'll pick the 20.5.
The center of the ladder?
Yeah.
You know the mass of the man, what is it? 80 kg.
Yeah.
So let's think about what vectors you know. So do we know this one, the weight of the ladder?
Yeah.
Yeah. Do we know the weight of the man?
Yeah.
Yeah. Do we know the reaction here? No. Here? No. And here? No. So I would choose this as the turning point because we cancel two things we don't know. and we can produce an equation that has two things in it which we know, and one thing which we don't know. So, if we take this as the turning point, we can solve this. If I know this, then I also know this. Why? Why? Equilibrium. It's balanced.
Sorry guys. Yes, I didn't jumper here.
No.
Okay. Alright, no worries.
You're leaving your clothes around the school again.
I don't know, somebody found my socks yesterday. Found my underpants last month. I don't know what to do. How to keep track of my body.
Look, we'll get you a laundry basket, okay?
Yeah.
Alright. If I come across it, I'll bring it to you. Okay, so why do we know this one down here? Well, because
the same force is pushing like up.
yeah, what's the key word I'm looking for?
Going into the turning point.
No. Equilibrium. The left force must equal the right force. Yeah. So if we know this, do we know this? Yes. Also, at the very beginning, we know the two down forces, don't we?
You said that the A question determines the vertical component, so the vertical component are
This one.
the two ways
The vertical component of the reaction.
of the force of the ground on the left.
Yeah, so this is what they want, which will equal these two added together. And is the next part determine the friction?
Or not?
Yeah,
So, yeah.
the friction. And this part will equal this. So for the very first part you don't need turning force, you can just say that this equals these two added together. For the second part you need to use turning force. Okay, see what answers you get there.
So 20.5 multiplied by 9.81
Plus,
plus
yeah.
18.
Yeah. As easy as that.
But how do we know that the one up equals the one down?
The top horizontal,
Yeah, because like in the one down we have two directions for the same force.
yeah, but how many forces are going to the right in this picture?
Only one.
And to the left?
Oh,
Yeah. You have it done already? Great. So, if I call this or this, we'll call this one F, and we'll call this one S. And this one, these two, we'll call them together W. You know that S going up should equal W going down, which equals mg going down. The total mass is 100.5 G. Yeah? So that would be, what's that, about 981 or something? I don't know, 100.5 times 9.81, what would be 0.905. So we'll say 986 newtons is the S. How many marks for that? 2? 3? Goodness. Right. The second part, I'll let you try. Again, my hint is to use this as the point.
So now they want the first and S, yes.
Yeah, we have S, so now they want F. If you find OR, you know F. Because OR equals F.
Isn't R equal W?
No, why would already put W?
We pick
Did you include distance?
yeah.
Yeah.
Yes. Oh. This is 4.5, okay.
The whole ladder is 4.5, yeah.
That's 0.8.
Yeah. So we'll have to, yeah. No, the distance, if you're taking this to the turning point, yeah.
4.5 minus.
Yeah.
What, 4.5?
And 0.8 this distance. So this is 0.8.
This is 0.8, okay.
Yes, and this is 4.5 minus 0.8.
Okay, and is that it? So yeah,
And this one is 4.5 divided by 0.8.
is it?
Yeah, it's in the, no, yeah, it's exactly the center.
1.8.
How is it 1.8?
It's very clear.
The whole ladder is 4.5.
Yeah, so .8 R equals 8.7. You have to divide it every, like, each one has to be by itself, right? Because each has a different distance.
Yes, but I'm not sure what you're asking.
0.8 R
Yeah?
equals,
Huh? 0.8 or?
yeah,
The distance is from the turning point.
4.5 R
Go on.
equals 3.7
Whatever, yeah. Yeah.
of
The W, yeah.
the man by himself.
And then also for the ladder as well.
With 2.7.
2.25
By,
times 20.5 G.
yeah.
Yeah. No.
Not the vertical.
Yes. You see, you've all forgotten something, which I'll just draw here. So you all had the right idea, but you forgot a very crucial piece of information, which I'll just draw here for you. So let me just look at the center, the weight for the moment of the ladder, okay? You're all right, it is force by distance, that is true. So this, what is this force here? What's the ladder, 20.5?
20.5.
Yeah, and is this clockwise or anti-clockwise? This one is, no, anti-clockwise, yeah, for this turning point. The force is 20.5 G, but the distance is not this distance. It is the perpendicular distance, so it's the distance from here to here
So 1.8.
divided by 2. So the distance you should be using is 0.9. Yeah. Now, let's work out the distance for the next one. What is the force actually? We'll just write it in. He's 80 at G, isn't he? Now, you know that this distance is 0.8. You know what's the total ladder? 4.5. So this distance is 2.25. So this is 2.25. So what's this little piece here? 2.25 minus 0.8, isn't it? 1.45, I think. So I'm just trying to get this distance here because I can add it on to the 0.9, you know? If I had this little distance here, I just add it to the 0.9 and then I'm finished. So I wonder, could I make a little triangle here? I think I could.
But we don't know the distance on the left side.
This side?
Yeah.
No, we don't, but there's a little trick here. There's 3 or 4 ways to do this. But I want to show you a way I haven't shown you before, which I think you might like, just something different way to do it. It's an interesting way to do it. we want to get this here, which I'll call it x. This length here. If we have this, then we're good. So, there's a word in maths, something that we don't do in maths, but this triangle here, we say it's similar to this triangle, meaning it's just the same except smaller or bigger, like you zoom in or zoom out. So we call the triangles similar. Yeah? The trick here is
1.5 over 2.5.
yeah, the ratio is the same. So you could say, for example, x over 1.45, that should be the same as 0.9 over 2.25. And in this way, you have a very quick, neat, easy way of getting the x here. So what is the x then, please?
0.9 multiplied 1.5.
Yeah, 1.45 over that. That seems about right. So we know what's the total distance then. But yeah, so it'll be 1.48 then. So that's what the distance you should use there, Ian. And finally, what's the last force? This one here. What distance do we use for that one now?
4.5.
No. Because remember, not even that.
Not even 1.8.
No, we need the perpendicular distance. So if I draw this force off to here, this is the distance I should use. So this distance here is the same as this.
Which is all of that minus this, right by Pythagoras.
Yeah, but once again, we can use our trick, because this full triangle, this full triangle is similar to,
Both of them.
yeah, any of these little triangles here. So let me just call this h, and how long is the full ladder?
4.5.
So I could say h over 4.5, oh no, we don't know, we would need to work out this height here, over 2.25. Well, since we got Pythagoras, we could just say square root 2.25 squared minus 0.9 squared. I use Pythagoras to get this, and then I can say this side over this side is the same as this side over the total.
This is a 5 months.
Yeah. Unsolvable?
Yeah, this is way.
No. You just need to practice them, that's all. What's the h?
But we found out that we need this.
Wait, hang on, I'm sorry. I think I'm doing this a very bad way at the end here. I just realised you were telling me about Pythagoras earlier, and Iyad, you were saying it too. I'm sorry. So let's forget about this. I totally forgot we know the total length here, and we know the total length here. So we can just do a h equals square root 4.5 squared minus 1.8 squared. That's much better.
Mine's all plus.
Minus because we're looking for this side. So a hypotenuse squared minus this side squared.
And if we're looking for any of the two sides, it's plus.
No, plus is only for the hypotenuse.
4.12.
Okay, great. We've got the h now. Right, so let's make our equation. So anti-clockwise, clockwise. So you have 20.5 g multiplied by 0.9 plus 80 g multiplied by 1.48. That should equal 4.12 multiplied by s. So then s is equal to that over 4.12. So s equals, therefore s equals. .12 newtons, so F is 72.12 newtons. Is there more to this B2?
No.
Okay, so what's B3 about then?
Atoms.
Great. Let's do that one now. Unless we did it already. What's it about? This isn't one about the patient again, is it? With the thyroid? No. Okay. Right, we scroll down and do it together then. What? Oh, this, yeah. We'll do the atoms one together. I want you to get this fully right. I believe in you. I believe.
What in
You guys.
Is this considered the hard question?
Which one? This one?
This part.
No, it's a normal turn in force question. Wouldn't be too unusual.
Compared to the rest of the exam. Like, it's a lot of work.
Is it? Oh, I've seen worse. If we wanted difficulty from 1 to 5, I'd consider it a 3. Where?
There is a 5 out of 5 in the exam.
Yeah, don't worry, I'll tell you when we get to it. But I've seen a very difficult mechanics question before that was very difficult. If you think this is a lot, it's not. It was to do with projectiles, but it was projectiles on a hill, not on the ground. Like, you had a hill and the ball was going down the hill, which I know might not seem like it matters too much, but it makes a big difference. Okay, continue. Right, let's do the atoms one together. So, what is it, A part 1, or what's the first part? Yeah, so what's the dealie?
X, A, Z.
Left or right? Right, of
Z,
course.
left.
Sorry, of course.
A, Z.
And the first question is, what is?
A.
Right, so everybody know what's the A for?
Protons and neutrons.
Yeah, nucleons, protons plus neutrons. Does it ask what it is called, or what? The name. Yeah, so what's the name of it? The mass number, I think, is one name for it. Do you call it something else in chemistry? Mass number, okay. Part 2?
Z.
What do you call the Z? Yeah. So how many marks do we have so far? 2, okay. Part 3 is explain them, is it?
What information?
Yeah, so the A is the number of protons plus the number of neutrons, and then there's going to be for Z as well, is it? Which is the number of protons, obviously. So right now, very, very quickly, I've clocked up 4 marks. You know, really good. Is it on to B now?
Yes.
Yeah, okay, so what's the B? Excellent, this is all normal stuff. So the penetrating power, and what else? Range. Okay, so firstly, penetrating power. What is that for the alpha, if you remember? Yeah, so what would we say here?
Weak compared to others.
Yeah, but like Ian was referencing an actual thing for his explanation, which is good. So yeah, so we could say that alpha can be blocked by the human hand.
So if I said weak compared to others,
it needs to be, the definition needs to reference something that you can actually like see and measure. You could, if you just said weak compared to others, well, that doesn't tell me if it's strong or weak. It's just weak compared to the others. But if the others are really strong, then weak compared to others. You know what I'm saying? Like, for example, if we were at like the Olympics, and I said that guy there is weak compared to the other athletes, he's still a heck of a lot stronger than me, you know. So it doesn't tell me enough by itself there. That's the penetrating power and the range. So what is the range? by that they mean, I don't know if you remember this, but how far out would the alpha particle travel? You know, the sort of, the range, the scope of it. Now, if you don't know, you have to just give some number. So, don't leave it blank. What would you say? It can be blocked by the human hand and has a range of, pick a number.
1 kilo.
You measure distance in kilometers? True, but it's not going to be that big. 1 meter. Yes. Because you just said it's weak, so it doesn't travel far. Right, is that B part 1?
Yes.
So what's part 2?
Same for big.
Ah, sweet. Beta, right. So beta can be blocked by what?
Foil big.
Yeah, a sheet of aluminium. No, a sheet of aluminium or something like that. Blocked by we'll say 1 centimeter sheet of AL. AL is aluminium, isn't it? And the range.
1 kilo.
Yeah, it's going to be bigger than the alpha, but not that much bigger. In other words, the question is, how far away would you need to be from it to be safe?
5 meters.
Huh? No, I think we need to be more like 10 meters. I think it's more like this. So, I'll have to double check the marking scheme, as I can't remember this one. But I'm going to say, and has a range of 10 meters. Oh, you can actually open it up there, can't you?
Yes.
Yeah.
Few centimeters. The first one few centimeters in the air and the other one few meters in the air.
Yeah, I think 1 meter might be the absolute limit. So this one is on the scale of centimeters. So maybe rather than saying a meter, we could say something like half a meter. But anyways, if you said a meter, I'd probably still give it to you. And the next one says a few meters.
Yeah.
So they didn't even specify a number. So if they said a few meters and you gave me 2, then I'd let you take 2. If you gave me 10, I'd take 10. Right, so we actually have full marks. How many marks have we got in total so far now?
8.
Not bad. Is there a B part 3 or C? Okay. C part 1?
Yes.
Yeah, what's the story in this?
Copy out and complete the following equation.
Oh, great, okay.
Rn 220 86.
Yeah. Decays or becomes?
Becomes
Yeah.
TO plus question mark.
TO, no numbers?
No.
Plus
Question mark.
question mark.
And there is an A decay on the arrow.
Ah, so it's an alpha decay. So straight away I know it releases what? What's the alpha particle? Helium, yeah. So helium, the numbers here?
2 4
4, 2. Yeah. So then what's this number here?
2 1 6
And this number here?
2 8 4
How many marks for that?
2.
Again, clocked up another 2 marks.
But they didn't have any like empty spaces to write on the field.
I know they maybe should have had boxes, but I think it's obvious because you need to have something with it to balance it. You can't just have this because it's not total correct.
The alpha is the helium.
Correct.
And
Helium 4.
Yeah. And the beta is the electron.
The electron, 0 to -1.
And then
No protons or neutrons. 0, 0 if you want.
you make it different.
Gamma like this.
Yeah.
0, 0 if you want to write something in. Okay.
Second one AC 200
Oh, another one.
yes,
Oh, right. AC.
228 89 beta decay TH plus question mark.
All right. Well, beta decay. So 0 -1. So this one is, and this one here.
9
2 more.
3 more marks.
Yeah. So like
10 12 marks.
12 marks so far. Yeah. Is there C, part 3?
No, D.
Okay.
A sample of magnesium 23 has an initial activity of 2.0 mega BQ and a half-life of 12 seconds. Part 1, determine the activity of the sample after 60 seconds.
Right, so the activity after 60 seconds, we can use this formula. A0 E minus lambda T. So that's 2 times 10 to the 6. E minus lambda T, and that's 60. So we have to work out the lambda. Do you remember the formula for lambda? Yeah, log 2 over the half-life, which is 12. So here it's log 2 over 12. So if we hit this in on the calculator, we get the answer here. Let's see what we get.
And I2 saying determine the decay constant of the sample.
Wait! The answer is the decay constant.
In the I2, not in the I2.
So this is an excellent example of where it's more convenient to do the second part first, where we should get the decay constant first because we need it for the first part. It is quite weird. So let's get the decay constant first. Log 2 divided by 12. You have it there? Let's double check it. 0.0577. And the units? Yeah. Sorry, that's squished in there. That's part 2. How many marks for that part 2? 2. And then we put that into part 1. So I'll just delete this and replace it with that number you just have there. That's quite weird. 0.0577. So shift E minus my previous answer times 60 times 2 times 62.5 kilo equals.
All of these questions are 2 marks each.
Yeah, so that's 4 marks.
There is only 4 marks left out of 10.
Is why we finished?
Yes.
That's it?
For the day.
Yeah. So you see, we very easily clocked up 20 out of 20, and we did that in 7 minutes?
We have 2 more.
Oh, 2 more, okay.
Determine the initial number of magnesium atoms.
Oh, well that's okay, because
Minus
we
A
have,
over the
yeah, A equals minus lambda n. So the n equals oh yeah, this should really have a minus, but we don't worry about that. I'll just write decay beside it.
Number of atoms.
Yeah, it can't be minus. So it'll be A0 and N0 because it's initial, is it? So that's 2 times 10 to the 6 over 0.0577. Yeah. So what do we get here?
Next part is the same as the first part, but the time is twice better than the previous.
34.7 times 10 to the 6 atoms. Okay, what's the next part now? Part 4?
Activity in 5 seconds.
Oh, that's exactly the same as the first part. So if I... Yeah, well I have to retype this. This is 0.0577 and replace this with a 5, and this was 2 times 10 to the power of 6. No. Ah. We'll put in kilo. 62.7. Yeah, I was expecting to be... Well, no, I was expecting to be more, but more than this. 62.7. What was the half-life? I wonder if I did something wrong with the 62 earlier. It is 2 times 10 to the 6 at the beginning, isn't it?
Yes. Multiply E.
So, at the very beginning when we did 60 seconds, we got 62 kilo. Yeah, and then when we have 5 seconds. Oh, okay, it's a different number. Yeah, much more. Actually, that's more like mega. 1.5 mega.
The exam we should write 1.4 meg,
Yeah, I'm just being sloppy.
yeah.
Well, no, actually, because the 8 here, you could round it up.
1.5.
1.5, yeah. 1.5 mega.
Even if it is like that,
Yeah, even if it said 3 significant figures, it would be 1.50. Yeah? You should be getting 20 out of 20 for the atoms questions, okay? You really should be.
hopefully there will be.
Yeah, hopefully there will be. Hopefully there will be. The only thing that is in atoms that we didn't do in this question, do you remember the other two things? The Einstein E equals mc squared, for calculating the energy and the binding energy. And then the HF with the work function and the wavelength formula, the H over mv. So there's only like 4 formulas in atoms, and that's all of atoms in 4 formulas. And the definitions are easy to remember because you do chemistry, like proton number, atomic mass and all of that. So what's the next question, just so I know for our next class what we'll be going on to? Of what the fields, atoms, electricity? No.
F equals 4 L over V.
Waves, we did study. This is the stationary waves in a pipe. Remember? Harmonics? First harmonic, second harmonic.
Do you think we should focus on exam papers more or on like trying to understand the lesson more?
Exam papers. Just be doing exam papers for the next 3 weeks. The most recent papers and go backwards in time. That's all you should be doing in physics at home, exam papers. Same for maths. Yeah.
You said we have to do question 6.
I think so.
I don't know, do we have everything I need?
Here, let's quickly write it up here. So what have we got here? We got a half-life of 110 minutes. So that's 660 seconds. No, I need an extra 0, don't I? Multiply by, 6,660 seconds. And we want to know how long until 99 of a decay. So we can say n equals n0 e minus lambda t. We want to have 1% at the end, and we start off with 100%. Sorry, I wrote that stupid. We want to have 1% at the end, and we start off with 100%. And the lambda is log 2 over the half-life, and the t is what we want here. So if I divide, I get 0.01 equals e minus log 2 over the half-life times t. So I log both of these, cancel that. So I get 6600 log 0.01 over log 2, that should equal the t. And you recall earlier I said that's about 12 hours or something. So let's see what we get here. 6600 times log 0.01. I lost my minus when I wrote the formula, but I'll fix the minus by just deleting at the end. Right, I'll just get rid of that minus. That's how many seconds, which is 12.18 hours, as expected. I lost a minus here, so there should be a minus there, which is about 12 hours, or half a day.
Yeah, the other one, number 8, is only 70.
I think so. A period of... Yes, but you're going to have to look something up to do with your... They don't tell you what the half-life of carbon-14 is. I gave it to you in class. It's like 5,000 years. You need to use this information to solve it as well. So there's not enough in the question to solve it. There must be some formula book with the exam that has constants in it. So, all right.
Okay.